Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, episode 21, Microgravity University. I'm Gary Jordan, and I'll be your host today. So this is the podcast where we bring in the experts, NASA scientists, engineers, astronauts, sometimes educators, all to let you know all the coolest information about what's going on in space. So today we're talking about the way students and educators are involved at NASA with Mike McGlone. He's an education specialist here at the Johnson Space Center in Houston, Texas, and we had a great discussion about the different programs here and how they influence students to pursue careers in STEM and STEAM fields, including careers here at America's Space Agency. So with no further delay, let's go light speed and jump right ahead to our talk with Mr. Mike McGlone. Enjoy.
Minus 5 seconds and counting. Mark. Launch commit lights are correct. There she goes.
Houston, we have a podcast.
Okay. Well, there's some, is Microgravity University, so I was doing some research, just to understand kind of the whole thing. Microgravity University is the parent brand, sort of, that kind of overarches, and MicroGenex is one of those things, right?
That's right. Microgravity University is an overarching, it's just an umbrella, it's not really an organization, but it actually started several years ago with, called RGOs, Reduced Gravity Opportunities. It was where teachers and educators and even students designed experiments to then come and fly on the C-9 aircraft, the Vomit Comet, and do those kinds of tests. But as that program phased out, they looked at other opportunities, and that's what we've looked at, like MicroGenex with the MBL, and now Microgravity University for Educators, which our current activity is then focused over on the Precision Air Bearing Floor, the PABF, over in Building 9, the Space Vehicle Mock-Up Facility.
Ah, okay. So what's special about that facility, then, that lets you do the challenges, I guess?
Well, the Precision Air Bearing Floor, if you think about it, is, if you've been over there, it's a large steel plate, it looks like.
Okay.
Polished, highly flattened to within, I don't know how many micrometers flat it is for the distance it is. But it basically works like a reverse air hockey table, if you ever played on one of those at an arcade or something. But instead of air blowing up to the floor, whatever item you have sits on pads that the air is then blown down to lift it up and give it a near frictionless kind of surface. So that allows us to do microgravity in 2 dimensions.
Oh, okay. Very cool. Well, so what I'm trying to imagine what kind of microgravity you can do in a 2-dimensional environment. What's a challenge that you can do?
Well, the challenge that we've come up with, we used last year and we're using it again this year, is we're doing a simulation that's very similar to, well, one thing that we do on the International Space Station where we're launching small CubeSats into orbit around Earth. Mm-hmm. We're taking it a little bit differently in that we're looking at a moving satellite trying to launch a small satellite into orbit around Mars. It's an orbital insertion. So if you can imagine a moving object that holds your satellite, moving away from a target that's moving almost left to right in front of you and firing an object to hit a target. Very challenging. Yeah.
So it's kind of like target practice, I guess, but in 2 dimensions and in microgravity kind of thing?
Right. And other than, standing still and hitting a target, you're moving as well. So you've got 3 different motions actually going on.
Wow. And it's really to simulate real orbital insertions?
Yes,
that kind of
yes, very similar.
Okay, very cool.
And adding in the robotics to it because it's supposed to be autonomous. Once they say go, turn on the air, everything begins to move. Then it has to respond on its own. So there's robotics involved with it as well.
All right. All right, let's pull back just a little bit because microgravity, we're kind of getting into the, already some of the challenges, but right. I kind of want to get like a full understanding of Microgravity University, just what it is and who does it, who participates, that kind of thing. So what's like the overarching, description of Microgravity University?
Okay. Well, Microgravity University for Educators, MAGOO, and I'll try to refer to it as that.
All right.
Is it's an opportunity. Let me back up. It's in the 2nd year. Mm-hmm. Last year was our inaugural year. We've only made a few changes to it this year. I'll talk about those. But it is an opportunity for educators and now students involved this year to bring this device to meet this challenge I just talked about, to design and build that back home, and then send a visiting team here to Johnson Space Center to test it there on the PABF. So that design challenge really brings in all across all the components of STEM, science, technology, engineering, and mathematics that we're really trying to reach out and engage students with.
Yeah.
And give them an opportunity to bring all that to bear on a very challenging, authentic learning experience, and then bring a team here to actually test it in our unique facility. So it's a bigger team back home than gets to come, but it's we're inviting actually 2 educators and 4 students, high school age students, to actually come here and do the testing.
And it's the educators from that school, I'm assuming?
Educators from that school. We're using the term educator as opposed to teacher because it's open to, it could be a school district. It could be tied in with an informal education as well. So it could be with a science museum or like a 4-H or a scouting unit, because those are education programs that have STEM outreach as well. So opportunity for them to take that on. So.
All right. Cool. So what kinds of, what was last year like? You know, how was the setup? Who came and then who participated? What was the challenge?
Challenge was very similar to what we're doing again this year. What was different was that the teams that came were only educators. Teams of 5 educators came. We had them from across the country. I believe, if I remember correctly, we had 9 states represented. No, that's not correct. 12 states were represented, including Puerto Rico.
All right.
And those were working, we had a variety of teams. Some that were working with one school or one program. We had some that were working across the school district. And we even had one team that was made up of the 5 teachers came from 5 different schools from across the country, from California to New York. Yeah, that was an interesting challenge for them. Not only what they were doing for us on the engineering, but just their learning how to collaborate together was a big challenge for them. We had a local team here from Clear Lake ISD as well, so it was quite a diverse group. Yeah,
definitely, all across the board. So then, the whole thing was, once you got, I guess, you put forward a proposal or something, right, to participate. Is that kind of how it starts? Right, that's how it starts. We send out information about the challenge and the technical requirements. There's a lot of safety they have to cover to be able to come work in Building 9, the Space Vehicle Mock-Up Facility, and work on the PABF. So we send out all that information and invite teams, like I said, schools, school districts, informal groups, or some combination thereof, to send in a proposal. And then we review those. We review them both from a technical standpoint. Some of our support folks in Building 9 will read it from a technical standpoint, and then we'll also read it on the education side, because it is an education event and outreach and a number of things. So we read it from the educator point of view. And our top 10 teams will get the invitation to come down and participate. Oh, okay. So anyone writes a proposal, anyone kind of puts this together, and then it's up to you to decide who's going to come down here for the competition. That's right. It's a nationwide competitive proposal process. We read them, we do we give them the rubric so they know what we're expecting and what we're looking for, all those criteria, and then, we do the reading. We always make sure there's 2 people that read it in each section just to make it fair, and then they just get simply ranked, and the top 10 will get the invite. All right. So then once they come here, what's that whole setup? Now you got it narrowed down to like the best of the best teams. So once they come here, what's that week look like? Oh, that week is very, very fun and very, very busy, as you can imagine. They will come in. We'll give them a chance. We've got to get them oriented, of course, to Johnson Space Center and the environment here. So they'll get a safety briefing. They'll have to go through, and even though we've read about it, now everybody's actually can get hands-on and look at it. So they'll go through a quick safety review. We'll make sure it can work on the precision air-bearing floor. And then we'll get a chance to test those. We'll give them a chance to go back and maybe make some adjustments and come back and test it again over the week. That's the gist of why we want them to be here, is to actually go through that process. To test it out for like the real thing, right? Right. Give it a real test. Not in a competitive nature from one to another, but for themselves, just trying to be successful going through that engineering process.
But the other things we'll do throughout the week, we'll give them tours of the overall JSC facility.
Oh.
We'll want to give them some unique experiences. I'm not sure what we're going to do this year, but last year we gave the teachers an opportunity to do a simulation in Building 16 on one of the docking simulators. They got to ride on the Mars exploration vehicle. They also got an opportunity to get on the partial gravity simulator, or POGO, over in Building 9, which is the old pneumatic. They put you in a harness and take the load off so you feel like you're on a spacewalk.
Wow.
So they did a lot of things I've never had a chance to do myself. It was a wonderful week. I had fun just watching them.
Yeah. Sounds like the microgravity part of Microgravity University you're taking to the fullest extent, right? Really putting them in a situation where they're experiencing it, where whatever they're designing is experiencing this microgravity and simulating it, right?
Exactly.
Yeah.
And even beyond that, using it back in their classroom, teaching about microgravity and that environment. And that brings in so many things for teachers as far as, Newton's laws and force and motion and energy and all those things they have to teach. But thinking about it from a standpoint that they often don't think about in the classroom is from that microgravity environment.
That's true, because maybe they don't, even without studying it, it's kind of hard to grasp, right? The idea that, you just know that everything goes down. You just know that you have, apples fall on your head. And when I'm sitting in this chair, the chair is going to stay on the ground, right? It's not going to float up and go towards the ceiling. But there's this whole different mindset when it comes to microgravity and how that applies to the International Space Station.
It really is, and it really has to put them in that mindset. You like you said, in our day-to-day situation, we don't deal with that. Here on center, we may even talk to astronauts and watch all the videos that come down from the ISS. But until you actually work and have to work in that environment where the friction, the things that we deal with, kind of unmask that real microgravity environment, is hard to do. You may know what happens, but until you actually start trying to make something work in one of those simulated environments, or I'm sure on board as well, it's a real challenge.
Oh yeah, and it kind of as part of this whole experience when they're here. Actually, is part of the experience kind of studying what the astronauts are doing on the International Space Station as part of Microgravity University? Are you connecting with them or studying videos or doing anything that sort of emulates what you can find on station?
Well, not directly with this particular experiment or experience. Pardon me. In a way, it is very similar to what the astronauts are experiencing, because they're on board working through. They're the person up there that is actually operating a lot of the experiments that are on board, or doing the experiments. Oftentimes they're the experiment themselves, with a lot of the human physiology that goes on. So in essence, that's kind of what our visiting team is. And we do try to make this parallel, is they're representing this whole team that is back at their school or district or their organization. So they have this team that is coming here to do this test and make what adjustments. And I probably should have mentioned this beforehand, but they really are going to continue that communication throughout. So if they, when they go through their first rounds of tests and maybe they find that it doesn't quite work the way they thought it was, we want to give them a chance to fix it, but not just the team here. We want them communicating with the team back home to actually make some of those adjustments. And that was something last year that the teachers found. It's going to be interesting this year with the students involved, how this is going to work out. But with the teachers last year, it was fun to watch them communicating with their classes back home. Because sometimes it was the student was the only one that knew how to really program it, of how it was going. It wasn't the teacher. So they were having to tell them to change this parameter or this setting, and then download it to their device and then do it. It was some interesting FaceTime conversations that I overheard and watched them doing, and holding up their camera, showing the device as it went, and hearing all these students, you should do this, no, you should do this, now let's talk about it, because they're trying to do it very quickly. So sometimes it seemed like chaos, but it really worked. It really worked out well, and was very exciting to watch how engaged those students were, because we were also live streaming it back to them as well, so they could watch through Ustream, an overhead view of each one of those tests.
Whoa, okay, there's a lot more going on.
Oh, there's tons of it's hard to even think of all the layers that are going on with this as well.
Yeah, I'm trying to get a full picture. So now you have, what's the setup of this giant air hockey table? Is it just like a big square? Is that kind of how
It's
it is?
a large rectangle.
Okay, all right.
Probably the size. I wish I could remember the dimensions off the top of my head. It is, I'd say it's roughly 20 by 40 feet, roughly.
Okay. So definitely rectangular. And then all of the teams are around it, or are they?
There's only really room to bring one team up at a time with the operators, the folks in Building 9 that actually operate it.
Okay.
The other teams are sitting on the floor, though. They're at Building 9, just off there. But we're actually using that video stream so they can watch it on a TV. It's just down below. They're not too far away, but there's just not enough room because it's elevated. It's about 4 feet up off the main floor. So the catwalk along there's really room for one team at a time. So, we really wish we had a large gallery and could get lots of folks up there, but it's rather hard to do. So.
I see. Yeah, and then so on the floor they have their phones out or something and are Skyping or FaceTiming real time.
Exactly.
Like their mission control, I guess.
A phone or an iPad, or I had them sitting there holding up whole laptops, trying to get the right angle to get it on their camera as well. So, yeah, it was fun to watch the different approach each team took to keeping up with that connection. And last year, one thing we were able to do, unfortunately we won't this year because this resource is not, unfortunately, no longer available to us. But once they completed their test, they got a chance to do a direct video conferencing link with their teachers and students back home afterwards. And I know a number of the schools had whole assemblies, during that hour of testing that they had at least on day one. Then they were able to go back and answer questions about how it felt to be there, about the whole environment, and that was really a fun thing to add last year.
Yeah, to add that, I guess, get a larger audience to really kind of experience it.
It was, and we hope that same thing will happen this year, but without that direct video conferencing resource we have, we're really relying on the teams to make that up with their own. They were doing it somewhat last year. We've asked them this year just to make it more part of their plan and to plan on that kind of connection.
Yeah, really, because it's almost like planning for just an operation, like a real mission here in Mission Control too. Because you got the folks on the ground, right? Quote, right. The ground supporting the astronauts up in space, kind of like that, right? You got your mission team up here doing this microgravity team, but then you got folks back home helping you out. Exactly.
It is exactly like that setup we have here between Mission Control and the folks on the station. And really, it took some of them between their day one of testing to their day two to actually figure some of that out after their test. We didn't lay it all out in front of them. It's a learning experience. So a lot of them made that connection second time around, and you saw changes like kind of randomly changing this. They came down all of a sudden. Then you saw them working with checklists and all these other things that we kind of expect to have in a mission, but. So they learned on the fly, which is great. Yeah,
that's exactly right. So it sounds like a lot of it is, obviously it's planned ahead of time, right? How long until you start the planning for the mission until the mission actually happens? Like how long is that stretch of time for Microgravity University? Or maybe application to mission?
Well, the applications have been out. They'll be due December 13th for that next go-round.
All right.
Give us, of course, with the holidays, a couple weeks to read them and evaluate them. We hope to have everybody lined up with their acceptance letters by mid-January, about the 15th. So from there until March 15th, they have about 2 months is all to design and to finish building this. Now, they've got a proposal already.
Sure.
Of course, everybody knows that from paper to actually building, there's always changes.
Yeah.
But so they have ideas in mind, but they've really got 8 weeks probably to just finish designing, build it, and send it down here to us. And be prepared for all this. So it turns around pretty quickly. The end of each team then gets a chance to come for 1 week. We actually have 2 test weeks, so 5 teams each of those weeks of the 10 that are invited. And so, yeah, it's a very fast turnaround. And then even there's follow-up because we expect them to go back, pull everything they did, their notes, their any data that they took, to pull that all together into a summary report, which then they'll share back with us as well. They'll do that remotely after the experience.
All right. So it's going to be pretty quick after the holidays here.
It is.
2018 is going to be rapid, like a really quick start to the year.
It is. It's coming very quickly, and getting all that stuff set up, working with Building 9 and getting the word out, yeah, it's a very busy time for me right now.
Yeah, for sure. All right, well, we're going to put this out before that December 13th date for sure, so maybe you'll get a couple extra applications, which
We're looking forward to it.
I'm hoping you're happy. Otherwise, sitting and reading over the holidays all these proposals, I hope I'm not putting too much work on you. But where's the website that can go to submit the proposal?
The website is a very simple one to go to. It is go.nasa.gov/NASA Magoo. That's NASAMGUE.
All right, Magoo is Microgravity University, but just condensed.
Condensed, yeah.
All right, Magoo. Or you can just you could probably just search Microgravity University, right?
Microgravity University for educators will take you straight to ours. You do want to add that for educators, because if not, you'll wind up at that overarching. But you can find it from there as well.
Okay.
We want to make it as easy as possible.
Oh yeah, definitely. Wow. All right. Well, it's going to be a fun time for them. So, okay, we talked about the challenge itself, and we did kind of allude to some of the stuff they're going to see. I kind of want to go back there, because some of the things I'm kind of jealous. I feel like I haven't even done some of these things that the students are going to do. So, the first one was the simulator, right? What was that one?
They worked in with Building 16, one of the engineering simulators there last year. I believe the one, because I didn't get to go do it either, so I'm jealous as well. But they got to do, I believe, one of the docking simulators.
As if you were, like, driving it, or as if, like, you were trying to capture a cargo vehicle?
I believe this was trying to capture a cargo vehicle over
Cool.
there. And I don't know if you've been in Building 16, where they have the dome projection of it's kind of a VR setting to a degree.
Okay.
Not with the goggles, but just trying to put you in that environment. You're at a station that looks like on board, and then they surround you with a dome with projection.
Oh, yeah. We actually just talked about that last week on last week's episode with Shane Kimbrough. We were talking about that very simulator, because that's the same simulator that he used to practice robotic arm operations.
Exactly.
So it was that. That's what it was.
These facilities are doing the same ones that our astronauts train in.
There you go. How about that? It's pretty cool from what they describe. Again, it's on the bucket list for me here. I still haven't done it, but it's literally a projection of the Earth, so it looks like whenever you're training, you're inside the cupola. You're inside the same module on the International Space Station with relatively the same view that they have. Obviously, Shane Kimbrough said it was not the real thing, but, it's pretty close.
It is pretty close from what I've seen. I haven't seen it recently, but yeah, it's a very nice simulation.
Yeah, and then you practice doing the robotic arms things, and they get no training, right? Do they actually go in and drive it? Do they actually run the simulation, or
Yes.
do they just watch it?
No, they actually go in and get
cool.
a chance to, not for a long amount of time. They usually go, their whole team of 5 or 6, so they each take a quick turn on doing it. Mm-hmm. So but they each get that hands-on opportunity.
Yeah. Wow. All right. Again, super jealous.
I agree. Like I said, I didn't get a chance to do those either.
Okay, so what's some of the other cool stuff they're going to see?
Well, definitely when they come down here, we want to give them a chance to see Mission Control.
Oh, yeah.
Building 9, of course, they're always working there. I mean, I think it's one of the highlights if you go on the tour from Space Center Houston or anywhere. It's always on the tour, but, there's a whole lot of difference from being up on the catwalk where the visitors are and being actually on the floor working for 2 or 3 days.
Yeah.
As I mentioned, they also get to do Pogo there, the partial gravity simulator.
That's
or at least
right.
is one that we've done in the past. The robotics group, which is also there, has been great to work with. Mm-hmm. As I said, last year they gave the participants an opportunity to take a ride. They didn't get to drive, but it's still a fun ride in the Mars exploration vehicle. The little car that was a joint project with, I believe, GM. That can drive sideways or sit and spin in one spot.
Oh, yeah, the MRV.
Yeah, the MRV.
Yeah, the MRV. That's a fun one, because it literally omnidirectional driving, so it can spin and go sideways, and that's a cool car.
They give everybody a chance to ride in that. Perhaps we'll do that again, or get a chance at one of the SUVs that are over there.
Yeah.
Don't know. Again, we're still in that. A few things we've still got to nail down between now and March, but there's definitely so many neat things to do here. We'll give them a chance to see the Saturn V over in the Saturn V building, cool. Which is always impressive, because we find most of the folks that are coming have never been here before. So
yeah,
I said last year we did have a team from the local Clear Creek School District, but other than that, everybody was really their first time to Johnson Space Center. So
yeah, maybe
it's amazing.
We might take that a little bit for granted because we go into work every day and pass literally one of the largest rockets, if not the largest rocket. I'm gonna have to double check on that, but that was the rocket that took us to the moon. So just laying on its side, just as we're driving by, and it's so cool it's like a hike to walk from one end to the other and see the whole thing. But it's definitely one of the cool things to see. Mission Control, definitely Pogo. That's a good one too, because you're kind of suspended on a string that sort of simulates, right? You simulates.
It does. It uses pneumatics and takes the load off so that you're suspended and actually feeling what it's like to be on a spacewalk. And they set up a nice little simulation to use handholds and move through 2 or 3 places and do try to make a connection of a cable into a socket, which. Again, if you're not used to that, when we're sitting here somewhere, that's just grab it and put it in there. Well, you're pushing against the floor and all these other things that aren't moving. Well, all of a sudden, everything's moving. You take tiniest push on that, and you're going the other direction all of a sudden.
That's right. Microgravity.
Microgravity at work. If you're not used to it, it's different, which I'm sure you visited with some of the astronauts. They'll always tell you that. But so this gives, us folks down on Earth a little peek into what that's like.
That's pretty cool. Yeah, no, that's true. That's you're talking about taking it back into the classroom. Newton's law of anything in motion will stay in motion unless acted upon by another force.
Or that action and reaction. That's the one that really gets you on that spacewalk. A little push here, and all of a sudden you're on the other side of the room if you're not careful.
That's true. Talking with different, astronauts obviously, but then extravehicular activity specialists too. The trick is the slower the better. Right, because if you move too fast, then it's exactly that. You're already in motion. Now you have to stop.
Right.
So understanding that whole thing, and now you got this 300-pound spacesuit that even in microgravity doesn't weigh that much, but it's still mass that you got to carry with you whenever you're moving. So
you got to carry with you. You got to stop it. You got to start it. Yeah, mass is still mass, no matter where you're at.
Exactly. And does that kind of translate into the challenge too? Is there a understanding mass and how it interacts with this whole setup here? And
it really does, because momentum, you get into force of motion, you've got all these other things, momentum and energy that go into it as well. And that's one thing that they do get a chance to work with. Of course, the whole device has some mass to it, but since they're, if you think about an old physics class about talking about momentum, maybe shooting a cannon, and the bigger cannon will shoot the same size ball further, just because of the mass differences. They do get a chance to adjust some of the masses on the launching device that their sled is connected to, so they have to take that into account. There, like you mentioned earlier, there's a lot of different facets to this that they really think through, and that's also why we focused at high school level for them to take it. Those that may have had the physics or a technology class that at least have been exposed to this at a little higher level. Definitely. Doesn't mean middle school can't be involved, but it's there's some pretty good science and engineering in here.
So that I kind of want to explore those layers a little bit more, actually, because I feel like what are they designing? What are they bringing to the table? And then what are the things that are here that they have to interact with? Like, what's the whole challenge then?
Well, the device that they're bringing, we provide them with, and this is similar to a number of design challenges that are out there in different places, is we provide them with a kit of some basic, simple materials. That is from cardboard to some dowel rods, some small pieces of wood, springs, rubber bands, bungee cords, things that'll give you the basics of a device, because in essence you're putting together this launching device. We call it the Satellite Launching Experimental Device, or SLED.
Oh, so you're building the launching device.
That's what they're building, is that device that's actually going to shoot a satellite. In this case, we use one of those little air hockey balls you might bounce around the kitchen. Yeah, the disc that's about 6 inches across. It blows air down, and you can bat it around. Yeah. That's the satellite that they're trying to launch from their device into the target. That's actually our satellite in this.
The satellite is the hockey disc.
Is the hockey disc.
Okay, cool.
So it's going to move very easily across that highly polished steel floor of the PABF. So they're building the device that's going to launch that, trying to hit this small insertion target that's moving.
Oh, the insertion target is moving?
Yeah, it's a moving item hitting a moving target. That's why it's there's a lot to this.
Yeah. Wow. Okay.
So they've got to decide, how to launch this, how fast it needs to go, which depends on, how much energy they need to put in this. Do they want to use rubber bands or springs or something more heavy duty? Mm-hmm. They do get a chance to enhance that kit that we give them with some things they have there as well, about 20%. It's an 80-20 rough guideline for them to use what we've provided and then design from their own materials that they have. Mm-hmm. And to me, the hardest part for them is to decide how to make that autonomous. Decide what mechanism they're going to use to release it at the right time, at the right speed to hit that target. Last year we had some that built their own breadboards. We had some that used the Lego Mindstorm robot to actually launch it, something they already had at their school. Yeah. And there are other options that other teams out there will find and make use of. Which is one of the funnest parts for me, is seeing the different designs that these teams come up with.
Yeah, a bunch of different designs for exactly the same task.
Exactly.
But, may the best design win, I guess.
Exactly. And once you actually, if you've ever been in one of these, it's not just the design, it's executing that design. So it's also building it so that it will withstand that launch and etc. So you've got to put some durability into it as well.
Kind of hard with cardboard and rubber bands.
It is, but they find ways. We had a team last year that took the cardboard box we sent them, which we didn't really have in mind at the time for them to use, but they used it as their basis and fiberglassed it.
Oh, all right. There you go. Way more structurally sound.
Exactly. So, using that, using their own creativity is really key to this.
Yeah, definitely. Wow. So they're here for a whole week then, and this challenge is it? You said there's a lot of testing involved in the beginning, right? You're kind of practicing and.
There is. It's over a week. So they come in on a Monday.
Yeah.
They get a chance that first day once they go through the safety review to spend an hour testing it on the floor, mm-hmm. which depending on how well it performs or what kind of adjustments they make, they can get one shot into 20 or 30, depending how well it works. We've got to work in that time for their experiences as well. Tours, the things that we will do.
Yeah.
And then a chance to do any modifications they need. And then they'll also get a chance then, and that's probably what Wednesday is. Then on Thursday they'll get a chance to work through it again and see if the modifications they've made work better. And they'll have about another hour on the floor to get as many shots in as they can and see what successes they have. Because that's what you're looking for, is not that they can do it once, but that you can do it repeatedly and fairly quickly.
Yeah.
Again, competing against themselves, how many times can they hit the target, so to speak.
Yeah.
And then we'll ask them to do a quick summary here locally, share, kind of a showcase what they've learned throughout the week, which we'll invite the JSC community to come and participate in as well.
Oh, really?
Like we do with a lot of these activities, yeah.
Cool. So real scientists and engineers from here at the center come and check it out.
They'll have that open invite.
All right, cool. So they have a lot of time to kind of refine everything and practice, because they come here on a Monday and by
Friday they're done and headed home. Bring that showcase. So they, really they get to spend about, out of that, 2 to 3 hours on the floor. So
wow,
it between all the teams, I mean, it's a lot of time. But an individual team gets about 2 hours on the floor is all.
Oh,
so.
That's right. Because you got to share. I didn't think about that.
Got to share. Yeah, got to share.
You got to share the floor. Okay. Wow, that's such a cool experience. Yeah, I had no idea that was something. Because when I'm in high school, I remember dabbling in all kinds of different fields, right? Because high school is kind of the time where you try to figure that out, right? Okay, what am I going to do for the rest of my life? So you kind of do some challenges over here, some things. Do you find that the students are more sort of set on, science and engineering is for me? Or do you find them kind of, this is another step on their exploratory mission of what they want to do for the rest of their lives?
Well, being the first time we'll have students here, my guess is that we will find most ones that are coming here are really interested in science and engineering.
Yeah.
But I'm sure that there are a lot that are on the team back home that are still checking things out.
Yeah.
And I'm also saying that from my experience. I'm a former classroom teacher, taught physics, and was a robotics coach.
All right.
So there's so many facets to this program as well. We'll give them a chance to design their own team patch, or like a mission patch and such, that you can really bring in a lot of different things. Matter of fact, I was one of our teachers last year was actually the French teacher that was involved, but she was also interested in science and engineering, and she found ways though to work this into her French curriculum and all sorts of things. When you get creative, there's lots of connections you can make because everything is connected.
We.
But for the students, it'll be interesting to see this year because we will survey them before and afterwards if this changes their feeling about STEM careers or be it science or engineering or technology or whatever it might be. We will ask that question, so we'll have some better data later.
Definitely. No, it's kind of the mission of why we do NASA, education here at NASA is to kind of, is that fair to say? Is that, this kind of helps inspire the next generation?
That is exactly what we're trying to do. I mean, that's what these are all about. Not only inspire those students, but give the teachers that are working with them the tools to help not only the students they bring this time, but students in the future.
Yeah.
They may get a chance to do this, or they can go do something similar on their own.
Yeah. So that's, maybe lesson plans are a part of this, right? Or is that another part of NASA education? There are lesson plans.
It really is. We don't necessarily design a lot of lesson plans here per se. We do provide a lot of curriculum material. We talked about microgravity earlier and learning about that.
Yeah.
We have an entire lesson guide on microgravity demonstrations and lessons that they can use, which we'll be sharing with the educators, of course.
Cool.
But what we're really trying to do is get them engaged in these unique experiences and really give them that opportunity for them and their students to experience it and work that into their long-term development as an educator.
Yeah. Okay. Right. Because you got educators here, right? The French teacher,
That's
and
right.
you got other folks coming that are going to apply this, right?
That's right.
That's very cool.
And that's one of the things we found last year is that they found so many ways to do. This is something in education that's called project-based learning. And a lot of them are not, they may do this on a small scale, but they found this as a way that they can do more larger problem-based lessons back home. It gave them the courage to go home and do that, the knowledge to do it. It was quite a deal. One story I want to share that I thought was just so motivating to me as well, that it's important we do these, is we had a teacher here doing a great job, having fun. It was obvious, but was, from my point of view, was actually shocked at the end of the week as he's giving us a breakdown of what he'd learned. Is, almost, I can't quote him exactly, but basically what he was saying was he had such a tremendous experience here and learned so much more about what he could share with students that he had decided not to retire and continue to teach.
Wow. How about that?
Yeah, it is very inspiring what they're able to do here and what they're able to take back and share.
A new wave of inspiration.
Exactly.
That's pretty cool.
So it's not just the young kids we're inspiring, it's those dedicated educators out there as well.
Yeah, decided to stick around. That's awesome. Not even retire. That's really cool. I could totally agree with the project-based learning too, because I'm thinking while you were talking about that, I was thinking about experiences in high school and earlier than that even, where I think the lessons, when it comes to like actual lessons that I learned and things I learned in school, the things I take away the most are whenever there was something very specific that I had to do. It was a task, right? That you had to start and then finish. And through that whole thing, you sort of can pull back and learn that broader piece of information, the whole purpose of why you were doing that project.
Right. That's what it's all about. We all know it works best, but sometimes putting it in action is not the easiest thing to do.
Yeah.
So this gives, educators a chance to learn how to do it and gives students a large immersion into this kind of activity.
Definitely. Well, what about you, Mike? Because you're here are you considered a NASA educator? Is that what you are, or do you have a different job title?
That's basically my job title, and
Yeah.
NASA Education Specialist.
Education specialist, yeah.
Do a lot of different things, design, this experience that we're getting ready to put together, which will involve so many different things, coordinate all that. So I'm kind of a program manager in a way,
Yeah.
but have to bring the education value to it, which is I think why, as a former classroom educator, it's that excuse me, that's a requirement for my job. So.
Yeah. How did that career path go? How'd you get from high school educator to the physics teacher all the way to NASA? How'd that go?
Well, actually, as I was trained as an educator in college, but went off in another direction for the nonprofit for a while. But I was coming back into education. I knew that I needed to refine my science skills again. Anything gets a little rusty when you don't use it. So I was looking for some summer opportunities to. I didn't want to just go back to school, but I knew if I looked, I could probably find some opportunities. And fortunately, actually, Johnson Space Center, there were some opportunities to come down and be a mentor for. Actually, that probably spend a week here at Johnson Space Center and work with students and find out all. And that's when I found out all the neat things that were going on here.
Yeah.
And did that. Got me hooked on NASA again, because I remember the moon landing. So it's always been there in the back of my mind. But what could it do for education?
Right.
Excuse me. And once I found out there were opportunities, I started looking for more, and I found them. I had opportunities to go and do different things. And finally, I found out, hey, there's a job I can actually go do this. I applied, and a couple years later, I was lucky enough, and here I am. It was a journey itself.
Yeah.
So, but I'm glad I'm here. It is very inspiring to get to work with all these educators and students out there.
Definitely. Yeah, I was a student myself when I first got here, and transitioned more towards the mentor role, and so I can appreciate all this stuff that you're doing because I lived it. I was there. I was definitely inspired to come work here through the internships and fellowships and all the other opportunities too. I worked with I did a rotation in education, actually working on various programs there. I actually did Reduced Gravity. That was one of the programs I worked with.
Okay.
Haas was another one. So what do you work with Haas at all?
I really work with them just a little bit, usually helping them during the summer when they have some students here when they need extra escorts for some of their tours and all. But as I mentioned, that program that I first had the summer to come and work for a week, that was the first year that they did Haas.
Really?
It was, and I was a mentor for one of those weeks during that initial year for high school aerospace scholars. So, yeah, I've worked with them off and on throughout the years as well.
All right. So, has it changed? Have you noticed since its inception?
It has. A lot of it is the same. They've refined. Really, what's to me the difference is then it was a chance to students just came and spent the week here and had a great experience, but they've added a lot of pre-work that the students need to do, an online course actually in preparation for coming and being here, and that's made it a deeper experience for the students. So that's been a great addition to it.
Yeah. And just to pull back even further, just for the listener's sake, it's a high school aerospace scholar, right? That's Haas, and it's kind of like Microgravity University, where it's a challenge-based course, and you come here for a week and do the challenge, right?
That's right. It's a series of smaller challenges that they do. Like it's designing and building a rocket, a small robot. So it's a bunch of small challenges that they do. I believe almost a daily kind of focus challenge that they do. Again, not working with it directly, I don't want to talk too much, but it definitely does have those elements like our large challenge for Magoo has, but just on a little smaller scale.
Yeah. Just from mentoring it, I know that they, at least for when I was mentoring it, they did like a Mars robotics challenge, and you had to design a rover and then do this competition where you kind of had this mat that was your Mars, right? Your Martian surface, and they had rocks and little shiny pieces of water, I guess, and you had to collect as much as you could, bring it back to your home base, and then however much you collected, then that's how you won, and that was the competition. It was pretty cool.
It is, and that sounds very similar to there's a version that's for community college students, and that's definitely what the community college aerospace scholars does, or what we refer to as INCOS.
NCOS.
Yeah.
Okay. Is that for Texas Community College, or is that
that one's nationwide?
Nationwide.
And
Very
actually, they do that one at multiple NASA centers.
cool. Wow. Education has quite a few programs going on, huh?
It sure does.
Yeah, that's quite a few. I know just under the Microgravity University, we talked about this competition here, but then also we kind of skimmed it over, but Micro G Next is another one, right? That's
Right. Micro G Next is another one. That one's, again, focused at graduate or undergraduate college level students.
Oh, okay.
And it is focused on, they work with the engineering team that works on spacewalking tools.
All right.
So they're given a challenge or two. They choose which one that they want, but usually there's two options that go out in the proposal. They choose which one they want to work on. They develop that, and then they get a chance to bring it here, and they work up a test that's actually performed in the neutral buoyancy lab.
Mm-hmm.
Students don't get to go actually dive and put it in, they work with the divers out there.
Darn.
Again, one of those little, shucks, can't quite do that. But they're there, they're watching it right on the monitors, they're getting feedback from the divers about how well it worked, how easily, what the ease with which they were able to utilize the tool.
Yeah.
So they get all that same engineering feedback, very similar to what the engineers here do.
Yeah. Wow. Okay, cool. So, a lot of these challenges are kind of based off of literally what is done here at NASA.
Oh, definitely. It really needs to be tied into what we're doing, either running parallel, like we mentioned. What we're doing is very similar to launching the CubeSats on the ISS, and it's very similar to, a mission, working with mission control. But as you get into the Micro G Next, some of the others, it is very much what they're, what they can be designing as a tool, that maybe that design works its way into a real tool.
Oh, wow. Have you seen examples of that? Have you seen examples of student-run projects that got fit into real?
Actually,
real
there's several, and let me throw in another program, throw it out there.
Yeah.
It's called Hunch.
Okay.
I cannot remember exactly what that acronym stands for, but it's basically high school students designing space hardware.
Okay.
And a number of different things. They've actually done some different challenges. One, space hardware. They've also done a food challenge where they actually come up with a new recipe, working with the food lab on that.
Sweet.
One thing they're testing right now on board the space station is footwear.
Oh.
I'm not sure what you would call it, a slip-on booty, a moccasin, space moccasin, whatever it might be.
Space moccasin sounds pretty cool.
There we go. Because you got to protect your feet up there, but what I understand the problem is they when they lock in on some of the handholds or footholds.
Yeah.
We're not used to having, tops of our feet, in that situation, rubbing some sore spots. So they've developed these space moccasins. We'll go ahead and use that term. And they're testing those right now on board to see how well they work. And they'll get feedback from the guys and gals on orbit, and see how well they work, or make modifications and try it again.
That is so true, because they do a ton of science all the time. They're working all the time. 250 experiments going on in any 6-month increment.
Right.
There's just so much work to be done, including maintenance and all that. But you don't think about you're not walking. You're working with your hands, and your feet are locked into these handrails all the time, constantly jamming into these metal handrails. Of course, they're going to get sore.
Right.
That makes so much sense. Wow. All right. Can't wait to see what these space moccasins are going to be on.
Yeah, let's see what I know they've worked on the dining tables and a number of other. Didn't brush up on that, but that's a great project as well. Again,
Cool.
It's called Hunch.
Yeah. All right. Yeah, the day-to-day stuff. That sounds pretty
That's
cool
right.
to work
That's
on that.
fun.
All right.
There's one thing you mentioned earlier, if I can throw out there. You
Yeah,
talked
sure.
about when you were an intern and others, how you were mentored through that program. And that's one of the things that we get with the microgravity teams that'll be invited to come down here during their design and building. And actually, while they're testing here, we're recruiting NASA, JSC personnel to be mentors, to work with them throughout that process, to be a technical advisor, coach, mentor throughout this as well. Of course, when they're working designing, they'll be visiting with them virtually, email or whatever they are doing there. But when they're actually on site throughout that week, especially during testing, we'll invite their mentors to be there with them and go through that. And the mentors have a lot of fun with that as well.
I can imagine, especially, I mean, you're working through these challenges together. Just any kind of challenge-based things. I could see anyone getting charged about that kind of stuff. That's really cool.
They are, they volunteer for it. We ask for volunteers. We're in that process right now.
Yeah.
So here's a shout out to anybody who wants to volunteer for that. But that's just another layer of the experience to have that NASA connection, with a mentor as well.
Yeah. Hey, that's pretty cool. You're coming to NASA, you're seeing all the cool stuff, doing real NASA challenges that are perfectly applicable to real spaceflight, and talking with NASA scientists and engineers along the way.
Right. And doing it in real NASA facilities.
All
at the same time. I mean, what else could we add to this?
All right. Well, Microgravity University, this is the place to go if you really want the true NASA experience. So I want to kind of end with just the overarching idea of education at NASA. Just talking about all of this, it seems pretty apparent, but if you can kind of put like a little, I guess because of the Christmas spirit coming up, a little star on top of this tree, or a little cherry on the fruitcake. Nobody likes fruitcake. What is the whole idea of NASA education? The purpose of why we do it?
Well, the purpose is to inspire and engage. If we're going to continue with exploration of the universe, it's going to take an educated workforce with lots of creative ideas and an understanding of what it takes to work out there, because it's not easy. It's not like being here. It's a different environment. It's lots of different challenges that we're learning more and more every day. We may, think we've solved one, but when we do, we discover there's 20 more that we have to deal with, wherever we're going, be it to lunar orbit or to Mars or beyond, whatever it will be. We've got to have people to do that are interested in this. So that's our job, is to inspire and engage and get those folks in the pipeline so that they can be involved down the road.
All right. That was a perfect way of wrapping it up, Mike.
I hope so.
Very cool. All right. Well, stick around till after the music here, and we'll recap that website for you of where you can apply to sign up and send your proposals to Mike here for Microgravity University and all the other cool stuff. There's more than just Microgravity University, so we'll kind of share that too. But Mike, thanks so much for coming on and describing all these cool challenges and the great experience that the students and educators are going to come do.
My pleasure. Looking forward to it.
Very cool.
Dock of the space shuttle.
Roger, 0G, and I feel fine.
Shuttle has cleared the tower.
Became a stage for all mankind.
Actually, a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Houston, welcome to space.
Hey, thanks for sticking around. So, as promised, here is the magic link where you can submit all of your good ideas, your proposals, to participate in the Microgravity University next year, as Mike said, in March. If you go to go.nasa.gov/NASAMAGOO, and that's NASAMGUE, Microgravity University. So that's where you can go and submit the proposal and find out everything there is to know about the program. If you want to know, and by the way, that's December 13th. December 13th is the deadline to submit those proposals. If you want to know all the other education programs going on, and sometimes, they're kind of scattered, so you got them going on all throughout the year. Some of them are in March, like the Microgravity University. I don't know, Haas and High School Aerospace Scholars is in more of the summer, but they kind of got spread out. But if you want to know all of the education programs, and maybe you're going to miss the deadline here, but you want to participate in the next upcoming one, go to nasa.gov/education. You can get a pretty good list of all the ones here at the Johnson Space Center, but then also all across the space agency at different centers across the U.S. If you want to know some of the things going on and see some pictures, if you kind of, didn't really understand kind of the visuals, Mike did a pretty good job of actually describing the visuals of how everything was set up. But if you want to see some of the programs here, just go to on social media at JSC Education. On Facebook is where you can find all the stuff going on here at the Johnson Space Center. At NASA EDU on Twitter is where you can find all the education programs going on across the agency. And then also we like to share things on the Johnson Space Center accounts. So like we say in previous episodes, NASA Johnson Space Center on Facebook, and then at NASA Johnson on Instagram and Twitter, it's there too. So if you want to have a question about the show, just use the hashtag AskNASA. Or if you have a question about how to apply or any of the education programs, use hashtag Ask NASA on any one of those platforms and go ahead and ask a question. And if you have an idea for this show, just make sure to mention it for Houston We Have a Podcast. This podcast was recorded on November 20th, 2017. Thanks to Alex Perryman, Danae Fullwood, and Stacy Welch. Thanks again to Mr. Mike McGlone for coming on the show. We'll be back next week.